So now, why do we need to combine everything? Right? What is the purpose? Why do we need to combine everything? Okay. So if you look at the piece of paper that I've given you, or the example that I've uploaded on Avenue to Learn. So those of you who are on Avenue to Learn, you can download these examples. Okay. So if we look at this structure over here. Okay. So we are going to analyze this structure later. But I want to explain to you the motivation. Why should we combine everything? Okay. So this is a real life structure. And I'm going to, pardon me, I'm going to get a notes, not notes, but a property. This is the one. So what you see over here, right? What you see over here, mechanical properties, okay, of a material. At the end of the day, the value of an engineer is by analyze, for example, by analyzing what is going on element H or what is going on in element K, we have to be capable of selecting the material. Okay? We have to be capable of selecting the material. Okay, and you cannot ignore any stresses. I repeat again, you cannot ignore any stresses at all. Okay, now let's look at this table. Okay, okay, then let's look at. So how did they get the property for this table? Right, we look at this table. Okay, yeah, I know. Okay, this is ultimate strength. Okay, I know. All right, this is use strength. Right, it's very this Young's modulus. Right, but if you look at the table in detail, you can also see a column where ultimate strength is in tension, in compression, and then in shear, and then in tension and in shear. Okay. Why all this value? Okay, why all this value? Now, did I teach you all when to use ultimate strength and when to use strength? Can you recall? Did I teach that yet? Probably not, right? When? Okay, let me ask you, when you use ultimate strength and when do you use strength? Can you remember? No? Okay, I'll tell you when. Okay. Right, so if we look at our textbook, okay, if we look at our textbook, so I should have done this earlier. So if we go to our textbook, I thought I did, maybe not. So if we go to our textbook, okay. Our textbook has this famous formula. I think you all will know the formula also. Okay, so we look at over here. Okay, so this is from a textbook. I'm going to copy from a textbook. Okay, I'm going to put it here. So from the textbook, it states what? Okay, you can see for yourself is that the factor of safety is equal to its ultimate stress divided by what? Allowable stress. Okay, it's equal to the ultimate stress divided by allowable stress. So over here, the ultimate stress is a material property. Okay, it's a material property. And the allowable stress is the analysis or calculated. Okay? This is where you calculate. Okay. Now I'm going to sketch the stress strain curve now. Okay, we're going to sketch the stress strain curve now. Okay, so most of you have done 3MF3, yes or no? Have you all done manufacturing course yet? No. Yes. Okay. So this look awfully familiar to some of you. So this is our strain. This is our stress. And you have this relationship. Okay. And then at this point, I'm going to divide them into two. Over here, this is elastic region. Over the other side is our plastic region. Okay, where intersect this dot over here, this is our yield strength. And at this dot over here, this is our ultimate strength. Okay, that is our ultimate strength. Okay. So for this course, 3ML3, we want to focus in the what? In the elastic region, yes or no? On the right-hand side is 3MF3, manufacturing class or manufacturing processes. Okay, in manufacturing product, you want something to deform in the plastic region, right? If you were to give me this pencil or this pencil, and I give you back the same pencil and I ask you to give me $10, will you give me $10? No, right? I have to change this, yes or no? Okay, so you have to put in under what? Plastic deformation. Now, you have seen this formula is from a what? Textbook, yes or no? You have seen this formula is from the textbook. And this table is also from a textbook. Can any of you comment what is right or what is wrong with this formula? Anyone? What is right? Okay, those of you online also, okay? What is right and what is wrong with that formula? Yes. Yeah. You should have used what? Use stress, right? But the textbook say ultimate. So you mean to tell me that the textbook is wrong? Have you heard this?
No. This is a practical formula, but in real life you cannot.
Yeah, but it's in your textbook. Right? What is right and what is wrong? Okay? I thought I teach you guys this in the first week. I did not teach you this in the first week. Hey? I did, right? So you guys say no, you cheeky sort. Okay? So I will skip forward. So you guys know this already, right? So for brittle material, that's why I asked you, I just waste my time, okay? But wait. So for brittle material, you have to use the ultimate strength. Why? Because the yield is very similar to the ultimate for brittle material. For ductile material, right, you use what? You use yield strength. Okay, good. So you all did remember this. Now, the next question is, how did they get this property from? Right? How do they get this property? So these properties, those of you have done my manufacturing class, those of you have not, it's okay. They did it. So the mechanical properties determined from uniaxial or unidirectional, not axial, unidirectional test. So what do I mean by unidirectional? Okay. Unidirectional means all these tests are done like this. It can be done in tension, or it can be done in compression. Let me copy this. Okay. It can be done in compression, or it can be done in shear. Okay. These are the direction, all. Okay. Right. Now, so that is why if you go back to the table, right? If you go back to the table, all these tests over here are done just by what? Tension. All these tests over here are also done in tension. Results over here are done in shear only. Okay? Then you ask me why they don't do it in combination. Then I ask you why they don't do it combination. Anyone? Yes. No. Why? 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 Think simple.
They only do worst case scenario.
No. It's the cheapest way. Okay? It's cost. It's the cheapest way to either do one tensile test, one compression test, or a shear. To combine them, the setup is not so straightforward. Okay? Now, question for you. Question for you is this. You now know that these are all done in one direction. Yes or no? Now you look at this structure. Is it under tension only? Is it under compression only? Is it under shear only? No, right? It's a combined set of loading. Yes or no? It's combined. Then how is it possible that we select the right material? That is why for this course, okay, you can use chat or whatsoever to post your question. No one there to answer. You want to know why? It's a combination of 3 topics. Axial loading. Sorry, 5 topics. Axial loading, shear loading, shear due to torsion, combined force analysis, and then the last one is what? Mohs circle. This is what true engineering is all about. At the end of the day, you have to be very confident and successful to calculate, to analyze the stress. Some of you might say, Eugene, I can use finite element. How many of you are working now? Your company use finite element software? Yes. A finite element software is worth $250,000 license. So my recommendation to you is this, okay? Get the company to hire you for $250,000 and you do the analysis for them. You don't need to use what? Finite element. Are we clear? Okay, that is the purpose of this course. Okay, it's the combination aspect. Now, I will make you go to the procedure, right? How to do this, okay? Now, coming back to here. All these are uniaxial. Okay, uniaxial. So we are going to put an element